Hi, my name is Talia. Welcome if you're new, welcome back if you're not. This YouTube channel is an extra resource for anyone who may be taking some chemistry classes and needing some help. This week I'm going to be talking about strong acid, strong base titrations, or just basic acid-base stoichiometry. This is kind of the Honors Chem version of titrations, and if you're an AP Chem, you'll also be doing titrations with like weak base, strong acid, and weak acid, strong base, and those are a little bit different. But today I'm just going to be going over strong acid, strong base titrations at a more basic level because I'm doing Honors Chem videos first. So I hope that if you would like to learn more about that, you will keep on watching. And without further ado, let's get started. Okay, so I'm first going to go over what a titration is. So a titration is when you use a concentration of a known solution, which is called a titrant, to determine the concentration of an unknown solution, and that is the titrate. So basically what you do with a titration is you have the titrate and you use a burette to drop in the titrant and you put in an acid-base indicator into your titrate, and when you get the necessary color on your acid-base indicator, you know that you have completed a neutralization reaction, and you use the volume of the titrant needed to neutralize in order to calculate the concentration of your titrate. So like I just mentioned, titrations involve neutralization reactions. And if you remember from, I believe it was Unit 6 when I explained different kinds of reactions, neutralization reactions are when an acid and a base yield salt and water. And just a reminder that a salt is an ionic compound. So, like I also already said, the objective of a titration is to determine how much volume of the solution with the known concentration is required to titrate the measured volume of the solution with the unknown concentration. So we can determine that mathematically, and today I'm going to show you how to determine it mathematically at the Honors Chem level with strong acids and strong bases. So we're just going to do a problem together. So the titration experiment is carried out between sodium hydroxide and hydrochloric acid. Give the balanced chemical equation for the reaction. 20 milliliters of 0.30 molarity sodium hydroxide is required to titrate 15 milliliters of hydrochloric acid. Determine the concentration and the pH of the hydrochloric acid and calculate the mass of salt produced. So I'm also going to add an extra part to this. We are also going to determine the concentration of the hydrochloric acid, because that is like the main part of what a titration is. But basically, to determine your theoretical information for titrations, you use stoichiometry. So I'm first going to write out my balanced chemical equation. I have sodium hydroxide and hydrochloric acid, and this is perfect because everything here is a +1 charge. So this is going to be an easy neutralization reaction where we're going to get NaCl and H2O. Now I'm going to draw out my table. I'm going to put moles, concentration, mass, and molar mass. Okay, so let's get started. We have 20 milliliters of 0.30 molarity sodium hydroxide is required to titrate 15 milliliters of hydrochloric acid. I'm also going to add a row in my table called volume. I relocated because I was sitting on the floor and it was getting kind of uncomfortable. So if we have 20 milliliters of 0.30 molarity sodium hydroxide, I'm going to put in that information. 20 milliliters is 0.02000 liters. And then our concentration of sodium hydroxide is 0.30 molarity. And then we have 15 milliliters of hydrochloric acid. So I'm going to put that in as well, 0.01500. Okay, so in order to figure out the answer to all of these questions, we first need to figure out how many moles of NaOH there are. And I'm going to do this by using my N equals CV equation. So I'm going to multiply 0.30 molarity by 0.02000 liters. And then I'm going to put that into my calculator to get 0.0060 moles of NaOH. So now we want to determine the concentration and the pH of the hydrochloric acid. So I first need to determine concentration. So I have my volume, and we know we can figure out concentration with C equals N over V. I have my V, so I need to find my N. So I'm going to do a mole conversion in order to get the number of moles of hydrochloric acid. So we have 0.0060 moles NaOH times 1 mole HCl over 1 mole NaOH, and that equals 0.0060 moles HCl. So if you notice, we are on our way to basically doing a titration experiment, but with math. We are theoretically figuring out the concentration of the unknown solution, and in an actual experiment, the way you would do this is you would measure how much volume of the base, in this case, that you poured into the acid, and you did that using a burette, and then using the same kind of stoichiometry process, you would kind of work your way towards figuring out the concentration of the acid, which we're doing. So let's figure out the concentration of HCl. Well, we have C equals N over V. So the concentration of HCl is going to be 0.0060 moles over 0.01500 liters, which is going to be 0.40 molarity. So that is the concentration of HCl. Next, we need to figure out the pH of HCl, because it says determine the concentration and pH of the hydrochloric acid. So I showed in my previous video how to calculate pH and pOH from concentration. So what we're going to do, I'm going to do it over here, is dissociate HCl into H plus and Cl minus. And we know that our concentration of HCl is 0.40 molarity, which means that our concentration of hydrogen is also going to be 0.40 molarity because there's no coefficient in front of H plus. So now to calculate pH, I'm going to do the negative log of the concentration of hydrogen, which equals the negative log of 0.40 molarity, which is going to be 0.40. Because the sig figs for pH start after the decimal point, so that is our pH of 0.40. Now we need to calculate the mass of the salt produced. So once again, I'm going to start with my moles of NaOH and convert them to moles of NaCl. So over here, I have 0.0600 moles of NaOH times 1 mole NaCl over 1 mole NaOH. And then I'm just going to go straight to calculating the mass because we don't really need the moles for any further calculations. So I'm just going to do one big conversion. But before I calculate the mass, I need to figure out the molar mass of NaCl. So that is going to be 22.99 plus 35.45, which is going to equal 58.44. So now over here, I'm going to write 58.44 grams over 1 mole NaCl. Make that look a little bit more like a G. And then we have moles NaOH cancel out, and so do moles NaCl. I made a mistake. This has one too many zeros here. So I'm going to do 0.06 times 58.44, and I get 3.5 grams of NaCl. I'm going to write that in my table. So now we have finished this stoichiometry problem. Normally in a titration, the things you would be caring more about are the concentration of the unknown solution as well as the volume of the solution with the known concentration, because that's kind of the purpose of a titration. So once again, in a titration, you would have your solution of an unknown concentration and you'd pour in a acid-base indicator using a burette. You pour in, like drop by drop, a solution of a known concentration, which is going to be a base or an acid, depending on what the solution that you are trying to figure out the concentration of is. So if you are trying to figure out the concentration of an acid, you're going to be pouring in a base like we did here, and vice versa. So then when you figure out the volume of that solution that you poured in, you can use stoichiometry in order to figure out the concentration of your unknown solution. And we just showed that here with the math that we did. Again, at the AP Chem level, these titrations are going to be a little bit different. The strong acid, strong base ones will be pretty much the same, but again, you'll be dealing with like weak acid, strong base, and strong acid, weak base. So I hope this served as a good introduction to titrations. So I hope you enjoyed this video. In the next video, I'm going to be introducing the unit of thermochemistry by talking about the difference between temperature and heat. So I hope that if you have questions about those topics, you will join me back next time. Feel free to leave any questions or comments you might have in the comment section below. I hope to see you in my next video, and good luck with learning the rest of your chemistry.